After the hybrid system is ready, and after you've selected a gear to go forward or reverse, the hybrid controller is going to look for the signals from the accelerator pedal position sensors. Electronic throttle controlled systems, ETCs, use accelerator pedal position sensors. The ETC systems use redundant inputs. Here on the left we have the accelerator pedal sensors built into one unit, an integrated unit, and it's going to the hybrid ECU. The hybrid ECU with the engine controller is going to monitor and look at feedback signals from the TPS to control the throttle position. These APPs are normal potentiometers that we're used to when we started working on TPSs years ago. We have a 5-volt reference, a signal, and a signal return or ground. They use redundant sensors, so we're going to have 2 APPs minimum. The Prius APP sensors on Gen 1 are potentiometers. The APP signals are sent to the hybrid control ECU. 2 signals are used for redundancy. The VPA is the main signal indicating pedal movement, and VPA2 is the redundant signal. Once again, we're going to have redundant signals. The 2 signals should show nearly equal voltage through the entire pedal travel, as we see here in this waveform. The signal will range from 0.8 of a volt to 4.4 volts from idle to wide open throttle. The APP, we said, reports to the hybrid controller, and the signals leave the sensors and go right into the hybrid controller. You can use DTCs to diagnose the APP sensors. Here we have 1120, and that's just telling us that we have a malfunction. The information codes will give us more information than the 4-digit codes, so we'll use those 3-digit codes. When you look at these codes, you're going to come down to testing the APPs, and it's just like we've been doing for years. Check power should be between 4.9 and 5.1 volts. And then, of course, check the grounds or the signal returns, and they should be less than 50 millivolts. If you have a code, the 3-digit code, the information code, 104, APP1, and APA1 signal is too low, check for an open circuit or a short to ground. 105, the signal's too high, check for a short to B plus or 5-volt reference. 106, the main accelerator position sensor 1 has an internal error. The signal voltage does not match APP2 or vehicle operating. It comes down to when you're looking at these sensors, you're going to look at powers, and that's at 5-volt reference on both redundant circuits, the VPA1 and the VPA2, and you're going to check for those signals. And they should be identical like we showed you in the waveform. And then, of course, the signal returns. They should be the same. The 107 is the signal's too low. You're going to check for an open circuit. If it's not a wire and it's in the integrated unit, powers and grounds, replace the unit. 108, both signals are too high. You're going to check for short the battery power. 109, the main accelerator pedal position sensor 2 has an internal error. Once again, VREF, signal return. The signal replace the integrated unit, no matter if you have 109 or 110. We're talking about potentiometers we've been working on for 30 years. 111 changes signal voltage when APP1 does not. So APP2 is changing when 1 doesn't. Once again, get your voltmeter, your labs, go out and check it. 112, 1 changes when APP does not change. As all you're going to do is look at both individual circuits. 113, the accelerator pedal position sensors appear to have an intermittent problem. And we've been sweeping TPSs for years, so we're going to do a sweep test on it. 114, we have a problem with the accelerator pedal position sensors. It does not return to the release position smoothly. Sweep test it. If it's sticking and you can't unstick it because of a rug or a dog toy, then go ahead and replace the unit after you check powers and grounds. Now, when we look at Prius Gen 2, the sensors are a little bit different. They're really not potentiometers. The accelerator pedal position sensors are non-contact Hall effect sensors. As you can see here, instead of a potentiometer, as the pedal rotates, we're going to move a magnet away from and toward the Hall effect devices, and that's going to give us our signal. When you look at it, it's very similar to the potentiometers, because we never look inside a potentiometer, and we're really not going to look inside the Hall effect. Once again, the circuit, the main circuit is VPA1 and the sub-circuit is VPA2, or the redundant signal. We're going to have 5-volt reference and a signal return. The two signals are used for redundancy. VPA is the main signal, with VPA2 being the redundant signal. The two signals should be nearly equal voltage throughout the entire pedal range, ranging from 0.8 of a volt to 4.4 at wide open throttle. So as we rotate it, we can look at the signal and measure the voltage. Now, the voltage signal from the Hall effect ICs vary with the rotation of the pedal itself. APP1 and 2 have approximately the same signal level. The Hall effect pickups are less likely to malfunction in dirty environments than the potentiometers. Idle voltage near 0.8 of a volt to 1.3, 1.36 volts should be equal. Mid-range, about 3 volts, should be equal. Wide open throttle, 3.6 to 4.4 should be equal. Sweep the throttle while observing the two signals on the DSO to identify intermittent problems. Use the codes. Here we have a 2120. The throttle position circuit is low. So we'd get our voltmeter out and we can check to see if we have the correct voltage reference. The ground should be good. Here 111 says that the APP2 changes and APP1 does not change. Here's 2121, the throttle position D circuit is low input. Once again, you're going to measure just like you do on potentiometers, no matter if you have the 105, 106, 104. If it has internal errors, you're going to check powers and grounds and replace the unit. Test any code the same way, no matter what the code is. You're going to check VREF, you're going to check the grounds, and you're going to check the signal. And you can sweep test with a lab scope for intermittent problems. Bill and I call that the 1, 2, 3 quick test. 1, check powers. 2, check grounds. 3, check the circuit. Other Toyota models are going to use the Hall effect type APP type sensors.